Oh my God.
So we live in a wild world, and nature has a tendency of doing what it does. To properly separate the environments inside of our shelters from the outside, one must consider all parameters in design for top performance. The envelope's got to be strong and durable, exclude the weather, provide ventilation, daylight into the interior, thermal and sound insulation, and prevent moisture from rising through the walls from the ground. When it comes to durability and strength, one can start with materials. They must be able to bear the different loads that are going to act upon the building, like the medial forces and dead loads created by the components of the building itself. And what about lateral forces? Strong winds and earthquakes. When it comes to earthquakes, stone and braceless concrete buildings are most vulnerable, while wood and steel frames provide the flexibility to withstand the forces. The walls must be tied to the foundation, and bracing and shear steel walls can be incorporated to create more flexibility. With wind, the force will depend on the angle at which the wind strikes the structure, the shape of the structure, the height, width, etc. Preventing wind damage involves strengthening areas where buildings can come apart. The walls, roof, and foundation must be strong, and the attachment between them must be strong and secure. And what about thermal effects? Heat causes building materials to change in size and lose natural moisture. From there, the objects can either retain the heat or quickly lose it, depending on their makeup. Thermal breaks can be installed in order to prevent the unwanted transfer of heat. So, you know how in buildings there's a constant flow of air? That's called the stack effect. It's a natural occurrence in buildings that results from the temperature difference between indoor and outdoor environments. The stack effect can have a significant impact on both energy efficiency and occupant comfort. During winter, warm air escaping through the upper portions of the building can lead to higher heating costs and lower indoor temperatures. Conversely, during summer, the flow of hot air into the building through the lower portions can lead to the higher cooling costs and a larger carbon footprint and warmer temperatures. To combat the stack effect, we need to control the airflow in the building enclosure. That means using things like air barriers, insulation, and mechanical ventilation systems. I guess the normalized leakage area is a fancy term for measuring how much air leaks through a building's envelope. This metric is an essential factor in determining the overall energy efficiency of a building, as higher levels of air leakage can lead to higher energy costs and reduced occupant comfort. To reduce the normalized leakage area, it is critical to properly seal the building envelope using air barriers, sealants, and other building envelope materials. By reducing the amount of air that leaks through the envelope, we can significantly improve energy efficiency and create a more comfortable indoor environment for occupants. Water penetration. Moisture can cause a lot of damage to buildings if it's not properly controlled. Rain penetration can occur when water enters a building through gaps or defects in the exterior envelope, such as cracks in walls or roofs, poorly sealed windows or doors. This can lead to water damage, mold growth, and even structural damage over time. To prevent rain penetration, it's important to have a well designed and properly installed building envelope. This can include features such as effective flashing, weather resistant barriers, and adequate sealing around penetrations. Regular inspections and maintenance can also help to identify and address any potential sources of rainwater intrusion. When designing the envelope, one also has to consider airborne sound, which is a sound that travels through the air. Typical examples of this include talking, sounds from the radio and television, sounds from pets like a dog barking, and the sound of cars starting or traveling down the road. Sometimes, due to poor standards of workmanship, the resulting gaps and cracks around doors and windows can allow sound to travel through the air, giving the sound access to different parts of the building. There are a few ways to minimize airborne sound. One way is through acoustic absorption. This decreases the amount of sound that reflects back into the air when hitting a surface within a building by treating floors, walls, and ceilings so that the sound becomes less prevalent. Another way is by the use of sound insulation. And one final way is by ensuring any holes, gaps, and cracks are identified and fixed to prevent sounds from being able to travel through to other parts of the building.